A ball is thrown straight into the air with an initial velocity of 80 feet per second. The distance in feet s of the ball from the ground after t seconds is st. So our function is s of t, and it's basically equal to 80t minus 16t squared. And for the first question, they ask, how many seconds will it take for the ball to strike the ground? Well, basically, if it's going to strike the ground, it means that the distance in feet of the ball from the ground is 0, right? That means st is equal to 0. So they're asking, where is st equal to 0? That's what they want to know. All right, well, let's figure that out. We'll set it equal to 0. So we'll say st is 0, have 80t minus 16t squared. Well, we can probably factor out the t here that's in common, correct? So we'll take out the t that's in common to both pieces, leaving you with 80 minus 16t. And that's equal to 0. Then we should be able to set those separately equal to 0. So we can say then that means t is equal to 0, or 80 minus 16t is equal to 0. Now t is equal to 0 is already solved, and let's make sense of that solution. That means that time is 0. That's when the ball will be on the ground. In other words, they're saying if they throw it, right from the ground. So the idea here is that we're neglecting the person's height, So we're saying if the person is standing there and throwing the ball, for example, up, then we're not counting the fact that the person is slightly elevated above the ground. Basically, imagine the ball is launching right from the ground. So at time 0, of course, the ball is already on the ground, and then it's going to go up into the air and then come back down and land on the ground. We're asking where that next point is located. So we don't really care that much about the first answer. That's kind of the obvious one. What we want to know is, how long will it take to go all the way up in the air and come back down and land on the ground? And that's what the second answer is going to give us. So if we solve that equation, it'll end up being 80 is equal to 16t, just moving the 16t to the other side, then divide both sides by 16. And finally, you will find that t is equal to 5, because 5 times 16 is 80. And so that's your answer there. All right, very good. Now, from there, we know the answer. It takes 5 seconds, basically, for the ball to go all the way up in the air, hit its maximum peak, and then come back down and land on the ground. Let's look at part B then. It says, when will the ball be more than 90 feet above the ground? This is a little more complicated of a problem. This is basically an inequality, right? So we're saying, when will the function be greater than 90 feet? So in other words, we're saying, when will st be greater than 90? Well, st is the same as what? The function 80t minus 16t squared, and we're asking when is that greater than 90? So that's an inequality. So if we move the 90 to the other side, we can set up a quadratic equation, right? So that'll end up being, let me write it in more traditional order, so minus 16t squared plus 80t, right? And then minus 90 is greater than 0. Why is that 90 minus? Because we moved it over, right? And crossing the inequality, it becomes negative there, right? Okay, now once we have that answer, we're basically just trying to solve a quadratic inequality. So you could simplify this a little bit by, for example, factoring out anything that is in common to the quadratic. You can do that. So for example, I might want to take out a 2 here. And in fact, I might even want to take out a negative 2. So let's talk about taking out a negative 2. If I pull out a negative 2, I will have positive 8t squared, right? Plus negative 2 here will actually give me a negative 40, right? If I divide 80 by negative 2, I get negative 40t. And then if I divide negative 90 by negative 2, I get positive 45. And that's greater than 0. Now, if I want to get rid of this negative 2 out in front, I can do that. I can divide both sides by negative 2 if I want. And if I do that, I have to remember a simple rule which says that what? When you divide by a negative in the inequality, you must flip the symbol. So by doing that, I'm going to end up with this new equation here, which is going to say 8t squared minus 40t plus 45 is now less than 0, right? Less than 0, because I divided by the negative 2. All right, from here, let's try to find the zeros of the function. It's kind of a complicated looking quadratic because the coefficients here aren't so nice. Let's go ahead and jump right to the quadratic formula just to be safe, because if it isn't factorable, we don't want to spend a lot of time on that. All right, so let's do the quadratic formula then to find the zeros. So t will be equal to negative b, which will be 40 in this case, plus or minus the square root of b squared, that's squaring 40. So we'll end up having 16 with 2 zeros, 1600 in other words, when you square the 40, minus 4 times the a term, which is 8, times the c term, which is 45, right? All over 2 times the a term, or 2 times 8. Let's just call it 16 to keep the arithmetic simple, right? All right, let's work out that piece underneath the radical. If you actually do that, you're going to end up with 40 plus or minus the square root of 160 all over 16. And then from there, we can simplify this a little bit. We could say that it's 40. Remember, 16 is 16 times 10. So if I do that, then I can take out the 16 as a 4, giving you 4 square roots of 10. So plus or minus 4 square roots of 10 all over 16. And then, for example, we could divide everything by 4 there. So 40 would be divided by 4 to give you 10. The 4 here would go away, and this would be 4. So you basically get the answer 10 plus or minus the square root of 10 over 4. So that would be your pair of zeros. Now, those aren't very helpful, though, the way they're written. I'd prefer to have decimals. So let's do actually the decimal version of that. So 10 plus the square root of 10 over 4 as a decimal is approximately 3.29, and that would be seconds, because remember we're talking about t, and t is time, right? And then we have the other one, the other 0, which would be 10 minus the square root of 10 over 4, and that's approximately equal to 1.71 seconds, right? And again, these are t's. So these are places on the x-axis, or in this case we'd call it the t-axis, but same idea, right? And when we do our graph then, let's try to put maybe 2 tick marks here to make each number. So this would be like 1, this would be 2, etc., right? 3, 4, 5. So if I want to know where 1.71 is, it's probably somewhere around here, right? And then if I want to know where 3.29 is, it's probably somewhere around there. Now let's think about the shape of this function that we're trying to graph. Remember, we're basically looking at this guy over here, right? This function is what we're working with now. 8t squared minus 40t plus 45. I don't need to know where the vertex is if I know that this opens up. If I know it opens up, the only way it could cross the x-axis the way it is to do something like this, right? It's got to do something like that. So I don't care where the vertex is actually, because I'm only interested in what? The question of where is it less than 0? Remember, the function is less than 0 when it's below the x-axis. So that would be there. And that's occurring between these 2 time periods, right? So basically the answer to the question is that we're somewhere between 1.71 seconds and 3.29 seconds. Or in other words, if you want to write it in interval notation, it's going to be 1.71 up to 3.29 seconds, right? That is the answer for the question. And of course, that's the place where the graph will ultimately be more than 90 feet above ground. And remember, the reason why we know that is because that whole equation over here came from this guy here on the left, right? So that's the location where we end up having the ball be greater than 90 feet above ground. It's the location 1.71 seconds to 3.29 seconds during its traveling path, right? So remember, it's only in air for a total of 5 seconds, because we found in the last part of the problem that from 0 to 5 is when the ball goes from the ground back to the ground again. So along that path, from 1.71 seconds to 3.29 seconds, it's actually above 90 feet in the air. And that's it.